Hi there, and welcome to this webinar hosted by ORS Consulting. So my name is Morten Nilstad Pettersen, and working in ORS Oslo, and also moderating this session today. So the topic for today is barrier management for aquaculture in exposed areas. So I will come back to you for a short Q&A session after the presentation. So if you have any questions during the presentation, please send them in by clicking on the Q&A symbol on the upper right side of your screen. So I will not keep you waiting anymore. So let's move over to Stavanger and my colleague Per Ståle Larsen. Are you ready, Per Ståle?
Yes, Morten, I am. Thank you very much. My name is Per Ståle Larsen. I'm a principal consultant and head of services in ORS. I have a Master of Science in Industrial Mathematics from NTNU, and I have more than 10 years of experience within consultancy work for barrier, risk and reliability services. I have experience from various industries such as oil and gas, maritime, aquaculture and renewable low carbons. But this webinar is not going to concern me much, Morten, so I think we'll go ahead with the presentation.
That sounds good.
Yes. So, the content of this webinar is I will give a quick introduction to the background and why barrier management for aquaculture can be relevant. Talk about barrier and risk management approach for aquaculture in exposed areas, application of barrier management for fish escape risk as an example of barrier and risk management, and also lessons learned from working with aquaculture for more than 5 years in this area. So the background. There is an expressed goal from the government that the production of Atlantic salmon, or the common Norwegian salmon, shall increase fivefold by 2050. And a relevant aspect in this context is that the country is divided in various regions, and you have a traffic light system indicating whether or not it is possible or it should be allowed to increase production of salmon in those areas. So the last 5 years, the production increase has been low due to environmental challenges in the industry. So you have problems with fish escape and with diseases, lice, various sort of challenges resulting in an inability to expand within the existing areas. So the government introduced a temporary arrangement between 2015 and 2017 called development licenses. They could be granted as financial risk reduction to companies with an innovative fish farm concept that contributed to reducing existing environmental challenges. Typically, this would entail either reducing the potential for fish escape or improving the fish welfare concerning lice and diseases. Currently, 21 companies or concepts have been granted more than 100 development licenses with a total market value of more than 1,500 million NOK. So in the pictures here, you see some of the concepts, some of the developments that have been granted these development licenses. The Norwegian Directorate of Fisheries issued a strategy concerning escape of fish from aquaculture. And this strategy document introduces the concept of barrier management as a necessary methodology or tool for converging towards the Norwegian government's zero vision for fish escape. This is a high focus area to make sure that the fish is being contained in their proper pens. And the reason for introducing barrier management include that fish escape statistics indicate that increased complexity in operational procedure and technical solution results in an increased risk for fish escape. And also, especially in light of these development concepts and moving of aquaculture to new areas, the current trend is that there could be a severe change in basic assumption concerning the design and operation within the industry. Conventional fish farm units, or all fish farm units really, under the Norwegian's Directorate of Fisheries jurisdiction, need to comply with, among others, Nytækkforskriften and NS 9415. So these are the main, I would say, the main documents or standards concerning the risk and fish escape issues. So the NS 9415 is tailored for conventional fish farms, which of course, if you are moving away from the fjords, it is likely to affect the concept, the design of fish farm, and which could make NS 9415 less applicable or less relevant. According to Nytækkforskriften, paragraph 4, there's a possibility to use European or international standards with equal safety level as basis for design of a fish farm. The basis, I would say the basis to go for would depend on the concept in question, but potential sources for determining design requirements to ensure safe design and operation include the Norwegian Maritime Authority, or NMA, International Maritime Organization. It could be class authorities or ISO standards. I'm going to say a bit about the barrier and risk management approach now. And the traditional way of describing risk is in an analytic context is probability times consequences, calculated through various risk values or categories. But I would say more modern theory, if you like, claim that this approach for defining risk is too narrow, and it limits the ability to understand, administer, and manage activities and enterprises. So on that basis, risk has been redefined really as being the consequence of an activity with the associated uncertainty. I think this is a very important point in this, in the context of this webinar, since it's bound to be a lot of associated uncertainty when you have this type of paradigm shift in an industry. So barrier management is coordinated activities for establishing and maintaining barriers so that they fulfill the functions at all times. The intention is to gain strength of knowledge for the barriers and reduce uncertainty in barrier performance. This is from the PSA definition, so the Petroleum Safety Authority. As mentioned on the previous slide, this transition of aquaculture to exposed areas introduces the potential for more complex situation of hazards and accidents, or DSHAs, with significant associated uncertainty and little to non-relevant empirical data. So there is this, I would say, inherent uncertainty, either from novel technology or novel application of known technology. Exposed areas in this context means areas with more adverse environmental conditions than in fjords. Typically, this would entail offshore or close to offshore locations. I've also included a couple of pictures. I think it's every time we talk about barrier management, it's more or less mandatory to show this Swiss cheese model, which is the cheese slices with holes in, demonstrating how you need to have barriers to avoid a hazard turn into consequences and losses. But the barriers could have holes in them, so you need to have a framework for controlling the barriers and verifying that the holes avoids the scenarios to develop. Application of barrier management. This involves hazard identification and barrier analysis. And the purpose, put plainly, is to identify required barriers and to reduce the uncertainty by defining a framework to verify barrier performance. in this slide, you can see a picture of a very generic bow tie diagram. This is one way of illustrating a hazard scenario and how various threats can result in accidental events or top events, and how the same event can result in defined consequences and the barriers in between to control these scenario or this potential. And also importantly, you see that there under the barriers you have what is called degradation factor or performance influencing factors. These are the conditions that reduce the barrier's effectiveness, i.e. the holes in the Swiss cheese. So you need to have degradation control to control these holes in the cheese. I'll get back to this later on, but I think this is one of the key lessons learned is the fact that this uncertainty or in the novelty concerning this shift in where you do aquaculture, it really emphasized the importance of stress testing the barriers to see where you could have potential holes and identify those so that you don't have weakened barrier in operation. There are many similarities between hazard identification and barrier analysis processes for a fish farm in exposed areas and, for instance, a unit in the petroleum industry. And a lot of the methodology that is being discussed here today is based on similar approaches in the petroleum industry. As the industry is also aquaculture industry is moving to more exposed areas, overlapping hazards include collisions, loss of stability, structural integrity scenarios, or fire scenarios. Also, other overlapping hazards could be the case, but of course you won't have any loss of well control concern if you have a fish farm. Aquaculture, however, introduce additional hazards related to other consequence parameters than normally find in the petroleum industry, such as fish escape and fish welfare. For instance, mass death scenario or large lice infection scenarios. Fish welfare in this context is primarily concerning events that would initiate emergency response action. So you wouldn't necessarily apply barrier management for the regular day-to-day monitoring of fish welfare, but it's more concerning the events where you need to have plans and procedure to adequately mitigate the situation. So since you have these additional hazards, then naturally the risk and barrier management framework and processes need to be adjusted accordingly. And then I'll go a bit more in detail on an example of how this application of barrier and risk management could look. In this example, it is concerning fish escape risk, which arguably is one of the risks with the highest focus and highest concern within aquaculture. On a principle level, there are many similarities between a fish escape hazard in aquaculture and a loss of containment hazard from the oil and gas industry. Both are reality concerning prevention and mitigation of loss of integrity. You have something contained and you want at all costs to avoid this substance being contained to be released uncontrolled to the environment. Typical fish escape hazards include cleaning, handling, wear of the fish containment barrier, subject to what type of barrier you have, of course. Could be collision, could be drifting objects. So this location in exposed areas introduces those type of risk. It would be loss of stability scenarios, structural integrity, could be load handling, it could be fish handling activities, or it could be whales and predators. Other hazards may of course also apply. And to determine the relevant hazards for fish escape, I would say it's recommended to consider hazards from conventional fish farms, where you get good guidance by NS 9415, a good overview of events and threats causes that needs to be considered in light of a fish escape scenario. And also new hazards that may be introduced by this novel design and operation. In any case, it's all about trying to make the hazards as relevant as possible for this design and operation that is being planned for. The barrier management processes have been established based on experience from the oil and gas industry, as mentioned. And this is not unique for the oil and gas industry. Barrier management is a type of risk management that applies for and is used in a very wide range of industries. And typically barriers follow this defined chronology, that it's concerning preventing something, to detect something, to react and limit, and to mitigate. The best, I would say, the traditional theory is that most emphasis should be on the prevent side, to have good barriers to avoid something happening in the first place. This is also, of course, the case here. So good preventive barriers would be inherently safe design, to have robustness and redundancy in design. Then here robustness and redundancy is, or called resilience as well, would be very valuable when you have a high degree of uncertainty to cater for a wide range of events. And also, of course, adhering to procedure and safety management systems as applicable. If you have a situation of a fish escape potential, you want to have methods to detect this. This could be alarm systems, or could be regulatory monitoring of containment barriers, or otherwise. You need to have systems and processes in place to be able to, as quickly as required, detect a fish escape event. You also need to have reactive barriers to be able to react and mitigate. Conceptually, they would be to remove the fish escape potential, to repair any breaching containment barrier before operation can resume, and adhering to emergency preparedness plan for fish escape. I would say, in order for barrier management to work, it must be done in conjunction with a risk analysis, and should as a minimum adequately cover hazards and barrier identification and frameworks to define necessary requirements and verification activities. I think it should be emphasized that when we talk about barrier management here, it's not necessarily the I would say quite strict theory defined by the PSA. It's a bit slightly more pragmatic approach, where the main goal is similar, but with a bit more simple approach, given the context and the companies that are relevant for this. I want to show some examples of how this can be visualized. So here I've made, this is an excerpt of, this is just a generic left side, you would say, of a bow tie diagram, where you have what is called the hazard, the yellow and black box. That is the latent hazard. So you have contained fish in a fish farm unit, and certain threats, the blue boxes, could create a fish escape scenario if you don't have barriers in place. I think here it's important to emphasize that these are not all risks or all threats that could give a fish escape event. These are certain threats, I would say, categorized as being of you see in brackets in the circle that is external cause. So this is, in this example, is concerning external vessels or objects that can damage or that can constitute a threat for a fish escape scenario. And here I've listed 4 threats. One being collision with field-related vessel, one being collision with external passing vessel, one being whales and predators, and one being drifting objects. And as you can see in this example again, that it's not necessarily the same barrier strategy that is taken for the different threats. For instance, for the whales and predators, this is something arguably you would like to include in design specs. So you need to have or you would typically want to have a design that is so strong that whales and predators are not able to create a fish escape scenario. Whereas for collision scenarios, it's much more difficult to design yourself out of it. It's impossible, more or less, to have a design that is able to withstand all collision scenarios. So you need to think a bit differently and have, for instance, navigational lights marking on maps, of course required as well, to have surveillance and to have, as far as possible, a structure and containment barrier that at least minimize the risk of this happening. For the collision scenarios with field-related vessels, there you have a much better chance of controlling it yourself. You can plan the operation, you can impose technical requirements on the vessel you use and so forth. So I think it's important when considering this that the appropriate barrier strategy is made for the individual threats. To show a bit on the reactive or the right side as well. So here in this instance, only the environmental damage consequences taken into account. Fish escape, of course, has many potential consequences concerning reputation and economy. There is environmental damage focus, and reactive and mitigating barriers would include monitoring of the containment barrier condition. This would, again, it would depend on what type of concept you consider, but in all regards, you need to have control of the condition of the containment barrier. I would also say, dependent on what type of unit is being studied, this monitoring could be also a preventive barrier if it is possible to monitor failure events that don't lead to fish escape unless they get to evolve or escalate. It could also be possible to have alarm systems sounding upon loss of integrity, and of course you need to have some sort of associated action upon detected breach in containment barrier. And here the same principles apply here, of course, as in barrier management in other contexts. All barriers need to be effective. So it's not the alarm system by itself is not enough. You need to have a crew with procedures and competence that also enable this the required reaction for any given scenario. You would also typically include barrier to remove the fish escape potential. This could be to have a temporary closing of any impairment in a containment barrier or other measures. And you need to be able to repair the containment barrier to more permanently prevent further escape. And also per requirements by the government, you need to have emergency preparedness plan for escape of fish. This would depend on what type of unit you have, how you do this, but you would need to have that type of predefined plan on how to go about in a situation like this. So I would like to say something about the lessons learned in the end. And I have a small picture. Again, it's from this example bow tie that I was shown earlier. And it's concerning this degradation factor, or the holes in the cheese, because this is, I think this is very important. But on a general basis, barrier management principles used in the oil and gas industry are relevant and fully applicable for aquaculture. Aquaculture, of course, and as mentioned, introduced new hazards, consideration that needs to be catered for by the barrier management. So this is, of course, it's true for not only the barrier management, but the risk management as a whole. You have other parameters to consider. It's personnel safety, it's fish escape risk, it is fish welfare. You have a quite big shift, for instance, compared with oil and gas, of consequence parameters that need to be covered by the risk and barrier management systems. Also, shifting of fish farming from fjords to more exposed offshore locations require competence and disciplines outside what is traditionally found in aquaculture companies. So when you move further to sea, and again, as a result of the increased complexity, you get new types of systems, you get new types of functionalities that the unit need to have, and those systems and functionality typically involves a different type of competence than you would have in conventional fish farms located in fjords. Shifting of the fish farming from fjords to exposed offshore location also requires fundamental changes to the business management system and procedures. I think this is very important because it's the entire both the safety management system, the safety culture, and the asset management. All aspects of the business management system need to cater for this shift in complexity and these new types of aspects that need to be considered in the exposed locations. And it is extremely important to have control as far as possible of the potential barrier degradation. Again, this is the yellow box, this is the hole in Swiss cheese. To, as far as possible, identify those and control them, both for the design barriers and for the operational barriers, meaning both the technical condition and the crew's performance and competence. Degradation and associated controls typically related to safety culture, barrier awareness at company and crew level, technical condition, and asset management. Many other aspects as well, but it's this to put it plain, it's the things that you don't necessarily see in the barrier. So you say you have a barrier, and that looks really good and appears to be safe and robust during project phase. It's being designed such and such with it's compliant with these and these standards and so forth. But they can still be sensitive to degradation once operations start. So it's really important to stress test the barriers in form of identifying potential degradation and having frameworks that enable you to verify barrier condition and, as far as possible, reduce the possibility of barriers not working the way they're intended to in an accidental scenario. Okay, I think that was that. Back to you, Morten. Is there any questions?
Thanks a lot, Ståle, for an interesting presentation. During your presentation, we received some questions, and also I could mention that we received an interesting link to an article as well related to causal analysis of escape of salmon and rainbow trout from Norwegian fish farms. So I think that article could give some further insights as well. So you can find it through the chat and Q&A function. So Ståle, are you ready for some questions as well?
Let us try at least.
That's good. So first of all, I think we have 2 or 3 questions covering the more or less same topic. So could you please elaborate a little on the applications for land-based fish farming or other types of fish farming? So the question is, can the same methodology be used there? or is it very specific for Norwegian regulations and the exposed areas? And I can also mention that there are a couple of other questions to the same topic, whether the methodology that you presented is valid for land-based fish farms, and also the difference between exposed and non-exposed locations. But we can take it one by one, Per Ståle. So please go ahead.
Thank you very much. It's a really good question. I would say, as a general approach, it is fully relevant and applicable to use barrier management principle both for other type of, let's say, sea-based sea farming, and also land-based. But of course, the difference would be that you need to consider the context and the consequences that are relevant. I have not worked much with land-based aquaculture myself, but I would assume, for instance, that fish escape would be less relevant. However, due to the way this would need to be done with the recycling type facilities, I would say it's very likely that you'd have more complex dependencies within technical system, for instance, and barrier management would be a good way to identify barriers and potential weaknesses in said system that are essential for having the fish welfare at the required levels. So I'm absolutely say that the methodology and the thoughts are fully applicable, but it's important also, of course, that you tailor it to the application in question.
Good. So could you also please say some words about the difference between risk management for exposed locations versus more traditional locations in fjords?
Yes, I can try. And I have primarily worked with aquaculture in exposed location. But one of the main, one of the differences I think is present is that is the idea of somewhat increased complexity. So when you move to more exposed location, you get a more complex operation and you get a more complex sequence of events, often for hazard scenarios. This is of course not saying that risk management for fjord location is easy, but I think it's one of the fundamentals and one of the main reasons in, for instance, the petroleum industry for introducing barrier management is this complexity, and how barrier management is a good method for events where you have where we need to have a series of barrier failures in order to have the major accident type of event. So again, I would say I think use of, for instance, bow tie diagrams and risk management principle fully applicable for conventional facilities as well, but the framework of managing the barriers could potentially be different, as it's different degrees of complexity.
Good. So one other question we received, whether there has been any accidents related to fish escape, I guess then for exposed locations, that could provide useful input for the barrier management processes.
Yes, there have been some events. They've been mentioned in the media when they have happened. I think that just I think the extent of the events have been, it's not been proportional with the amount of fish, but still there has been event, and I think that at least for me it emphasizes this, that the potential degradation of the barriers. I think that in many cases the barriers by design are good, and but because there's not because the condition of the barriers or the degradation factors are not entirely known, you see that they don't work as intended, and it at least for me, it further emphasizes this the value of stress testing the barrier or identifying potential holes during project phase, both project phase and operation.
Good. So, Per Ståle, I realized we could spend the entire day talking about this topic, but I suggest that we wrap up now. So I would like to thank all of you participating in the webinar for listening in and also giving interesting questions. And also a big thank to you, Per Ståle, for giving an interesting presentation as well. So we will continue with the webinars, and we have some interesting topics coming up. So please follow us on orsconsulting.no as well as LinkedIn for more information on future topics. So once again, thank you all for joining this webinar, and have a nice day and weekend.